In this video, I'm going to look at correlation analysis. This is a statistical approach which looks at two sets of numbers to try to determine how closely they're related. It doesn't say anything about causation. It doesn't say one set is causing the other set. It simply says if there is a relationship or not. If there's a very, very strong relationship, the correlation coefficient would work out to be 1. 1 is they are identical sets of numbers, or the relationships are moving in exactly the same way. That would be a correlation of 1. So a correlation of 0, there's no correlation at all. The numbers are randomized. They're not following each other at all. So we're looking for a number between 0 and 1. Inclusively, of course. It could be 0 or it could be 1 or any number in between. And what we'll do is we'll use Excel to try and work these out for us. If you haven't got Excel, don't worry. There are free suites of programs available on the net which will do exactly the same, and which are, as I said, they're free to download and they're excellent products. So if you haven't got Excel, you can get a free one downloaded, and I'll make the addresses for these available in the class notes elsewhere. But for the moment, this is what we're going to attempt to do. So we'll start by looking at this set of numbers here. We'll say there are 25 students, beg your pardon, 25 students, and they each do an examination in mathematics and science. Now, for some reason, mathematics is marked out of 200. Perhaps there are 2 exams of 100 each, and they're added together. And science is marked out of 6. That was the rule for the examination, and we will follow it. A test or an examination marked out of 6. 6 is the highest score. And what we want to do is to see how these two are related. Now, I've drawn or inserted, I should say, the chart showing these two relationships. I should show you how to get the chart, I suppose. Let's just delete that for a moment. To work out the chart, it's very, very simple. We just highlight the numbers we want here. We go to Insert, we'll go to Scatter, and we'll pick this one here and move it across. And this is the chart we just had a moment ago. As you can see, the chart shows the variability in mathematics and the variability in science. In fact, that science one is not good. You can't truly see the peaks and troughs of the graph, and it's difficult to see that in conjunction with the mathematics. It's the numbers here are too small compared to these numbers, so it's not easy to make a comparison. You can see the ups and downs here are difficult to determine. This one is easy, up and down and so on. So what we need to do is, I think, is to process these raw results to something more meaningful. So what we'll do is duplicate this set of results. Just put them over here for a second, and then I'm going to pick any point along here, any student number. Take row 13, for example. Now, in mathematics, this student got 131. I'm going to make that equal to 1. So if I divide 131 by itself, I get 1. So here it is here. Let me just make these yellow as well. So 131 divided by 131 is 1. 163 divided by 131 is 124. 136 divided by 131 is 104, and so on. And what I've done simply is I've used the formula. If you look at the formula up here, I've got B13 divided by B13 divided by itself, which is equal to 1. I've put in the dollar signs here to anchor this so it doesn't move. This is a constant in this calculation, so when I work out the next one along, you see it's B12 and it's still B13. The dollar signs means it's anchored. So what I did was I did that, and then I just dragged it up and dragged it down, and this is my new set of results from mathematics. It's based on this one. I've picked 13 to be my base number and worked out the index based on that. So I've got a column of, it's an index column of results for mathematics. Now I want to do the same thing for science. So I do it here. I take 3.4 divided by 3.4, which is 1. 2.6 divided by 3.4 is 0.76. And you can see the formula on the top goes exactly the same as I had before. So now I've got this new set of data. Now what I'd like to do now is to have a look at what's this look like in terms of a chart. So we'll go back, insert, and we'll do curves again, and there you go. It's that's much better than the previous one. The previous one was, well, we couldn't make a comparison, but this one we can. You can see where science is, you can see how variable science is, and you can see mathematics. You can also see there are close similarities, some parts. Here it's not, here it's good, here they're matching, here it breaks down a little, here it's matching but it's not exactly the same, but it is matching. The little dip is the same as on here. Anyway, so there we've got the comparison. Now what I want to do is to get rid of that for a second. I want to compare mathematics and science together to see what they look like. So I'm going to do yet another little graph. Take scatter diagram, and I'll take here as well, and put it in. That does not look pretty. That looks pretty bad. If I try to clean that up, it's not going to make a lot of difference. You can see it's an upward trend, an upward or downward trend, upward trend. So as mathematics gets better, so does science get better. It's not saying one's causing the other. It just says, you know, as mathematics increases, the score increases, science score increases. There's a lot of variation. So a bit of a mess really. What we could do is click on here. When you click on here, you get a new set of tabs on the top up here. Go to the layout one, and we'll go to Trendline. Let's just fit a straight line. Okay, so it does suggest it's there is a positive relationship between the two of them. That as mathematics gets better, science gets better, and vice versa, I suppose. Depends on what's the dependent and independent variables. We could also go to more Trendline options here. We can insert an equation and the r squared, which is here. I'll make that bigger because it's easier to read. I'll go 14. No, maybe go 16. Right, let's move it across. So yes, we've got a positive sign here. There's a plus in there we don't write down. So there is a gentle upward slope. The R squared is the correlation coefficient squared. It's squared because it becomes a new statistic called the coefficient of determination, which simply means that it's suggesting that one is determining the other. It's going further than simply an association between the data. It's not saying causation, but it's saying it looks like one is determining the other, and the extent to which it's determining the other is 0.54. So more than half the variation in science is caused by, or is related strongly to, changes in mathematics. And that's just a correlation coefficient. I can do that here to show you. Let's just do the correlation between those two. Sorry, let's do it this way. Okay, we'll go to here, insert a function, and we'll go to statistical, and then we'll come down to correlation BC correl. Now it's asking me for the numbers here, so I'll put in it's F2, so F2 colon but F2 26 to F26, and the second array is G, so it'll be the same, so G2 colon G26, and that's the correlation coefficient. So that is the correlation coefficient between mathematics and science as worked out here. We want to get that one, so what we'd do is we'd square that. We'll just put it over here. So what I'll do is I'll enter a formula here, equals, so it's I18, I think, I18, and to square it I use this little, it's like a little hat there, and I'll say 2, so square to the power of 2. That's what that little sign means, to the power of, and click it, and we get 0.54162, 0.54162, I presume. Excuse me. So that shows the correlation coefficient is just that one. So you can do it just using the fx approach, or you can actually work it out using the trendline approach. So that's how we would work out correlation coefficients in practice using a spreadsheet. It is possible to work out correlation coefficients by hand. It's very complicated and very messy. It's easy to make mistakes, but that's the way we should do as well. And to have a complete understanding of the complexity of correlation, it's necessary to be able to work it out by hand, but that's for a different video at a different time. As far as we're concerned here, we can use the facility of the spreadsheet to do it. Many calculators also enable us to do this. So that's our brief look at correlation. We'll conclude there. So many thanks for watching.